Properties of solutions. Most of the substances that we encounter in our everyday lives are elements? No. Compounds? No, not compounds. Mixtures? Yes. Most of the substances that we encounter in our everyday lives are mixtures of substances. And some examples are wood, milk, gasoline, shampoo, steel, the air that we breathe, and we could go on and on. When we talk about solutions, solutions are homogeneous mixtures. That means that the substances that make up a solution are uniformly mixed together. And when we talk about the substances in a solution, the solute is the substance that's being dissolved, and the solvent is the substance doing the dissolving. Like if we look at a salt water solution, the salt is the solute and the water is the solvent. When we talk about solutions, we often consider a solid dissolved in a liquid, and that is one example of a solution, but there are lots of others. Solutions can be a gas dissolved in a gas. Like the air that we breathe or natural gas is a homogeneous mixture of several different gases. Solutions can be liquids and liquids. Like antifreeze in our cars are an example of a liquid-liquid solution. Solutions can be solid and solid. Like brass is an alloy of copper and zinc. Solutions can be gases dissolved in liquids, like when carbon dioxide dissolves in water. Like when we drink our soda, we've got carbon dioxide dissolved in the drink. They can be solids dissolved in liquids. And again, that's probably the most common thing we think of when we talk about solutions. Salt water is a good example of that. Or they can be a gas and a solid, like the combination of hydrogen in platinum. Now, when we describe solutions, we need to talk about several terms. Our first term is dilute. And we say that a solution is dilute when it has a relatively small amount of solute relative to solvent in the solution. Concentrated refers to a solution that has relatively large amounts of solute dissolved in our solvent. When we say a substance is soluble, we say that it has the ability to dissolve in a given solvent. And if we say a substance is insoluble, we're saying that it cannot dissolve in a particular solvent. If a solution is a saturated solution, it means that it has the maximum amount of solute dissolved in it. So if we were to add any more solute to that solution, it would not dissolve. Unsaturated solutions are ones in which we don't have the maximum amount of solute dissolved, so more solute can be dissolved. When we talk about solutions, we want to deal with the quantitative analysis of solutions, or in other words, we want to deal with numbers. How much solute do we have in our solvent? What's the concentration? And there are lots of different ways that we can refer to concentration depending on what we want to do with the numbers. So one way we can talk about the concentration of a solution is by dealing with what's called molarity. The shorthand for molarity is a capital M, and we can see the word mole kind of in that. Molarity is the moles of solute per liter of solution. We can also describe the concentration of a solution by doing a mass percent calculation. And a mass percent calculation, like any percent, is your part over your whole, or it's the mass of the solute in the total solution. So we would take the grams of the solute divided by the grams of the whole solution and multiply it by 100. Often we'll talk about what's called a mole fraction. And a mole fraction is the ratio of the moles of the component we're studying to the total moles in the solution. So if we have a solution that has A and B as its components, the mole fraction of A would be the moles of A divided by the moles of A plus the moles of B. Molality is another way we can deal with the concentration of a solution, and it looks a lot like molarity, but it's a little bit different. We're going to use a lowercase m to signify molality, and it's moles of solute, but it's per kilogram of solvent. So there are two things that are different about molality and molarity. Molarity deals with liters of entire solution, whereas molality deals with kilograms of just the solvent. So molality is moles of solute per kilogram of solvent. So let's look at a problem. Let's say that a solution is prepared by adding 5.84 grams of formaldehyde, and it gives us the formula, to 100 grams of water. It tells us that the total volume of the solution is 104.0 milliliters, and we want to calculate the molarity, the molality, the mass percent, and the mole fraction for our solution. And we're going to assume that the density of water is 1.00 grams per milliliter. All right, so let's list what we need to know first. We know that molarity is moles of solutes per liter of solution. Molality is moles of solutes per kilogram of solvent. In order to calculate mass percent, we need to know the mass of the solutes and the total mass of the solution. And to figure out the mole fraction, we need to know the moles of our solutes and the total moles of solution. All right, so we're going to have to do some work on the numbers they give us. We're first going to take 5.84 grams of H2CO, and we're going to convert that to moles. So 1 mole equals 30.03 grams. Remember, that comes off the periodic table. So that's going to give us 0.194 moles of our solute. And if we look, we can fill in some of these numbers now. 0.194 moles, 0.194 moles, and 0.194 moles in the numerator, and 0.194 moles as part of our total moles of solution. So we filled in quite a bit just by calculating our grams of solute. Now, let's look at our volume. It gives us 104.0 milliliters, and we know that there are 1,000 milliliters per liter, so we can plug in 0.1040, and that'll give us our volume of our solution. So the molarity of our solution is 1.87 moles per liter, or we could say that it's a 1.87 molar solution, Kilograms of solvent. All right, so when we look at the problem, it tells us that we're using 100 grams of water, that's our solvent. We need it in kilograms. There are 1,000 grams in a kilogram. So that's going to give us 0.1000 kilograms. So the molality of the solution is 1.94 moles per kilogram, or we could say it's a 1.94 molal solution. Now for the mass percent, it actually gives us what we need for that. We've got 5.84 grams of solute. The thing we have to be careful of is we want the grams of the total solution in the denominator. So 5.84 plus 100.0. And we're going to multiply that by 100. And that's going to give us a 5.52% by mass solution. Now the last thing we need is the moles of our solvent. So it tells us in the problem we've got 100.0 grams of water. And we know from the periodic table that 1 mole is 18.02 grams. So that's going to give us 5.55 moles of water. So we can plug that in for our mole fraction. We've got our part over our whole, and that'll give us our mole fraction. So we're going to get 0.0338 for our mole fraction. Now we could multiply that by 100 and it would tell us that it's a 3.38% by mole ratio, but we're going to leave it as a decimal. It'll make it easier for what we're going to do later on. Alright, so let's look at another one. What is the mass percent of sodium chloride in a 10.0 molal solution? Alright, well it doesn't give us specifics this time. It tells us what the concentration is. So we're going to make an assumption. Let's assume that we've got 1.00 kilograms of solvent, which is water. So our molality is moles of solute per kilogram of solvent. So it tells us we've got 10.0 moles per kilogram. So we can find out how many moles we have. So we've got 1.00 kilograms. That's going to give us 10.0 moles of sodium chloride. We can convert that to grams. 1 mole of sodium chloride is 58.44 grams. So that gives us 584.4 grams of sodium chloride. So our percent by mass can now be figured out. We've got 584.4 grams of sodium chloride. The total mass is 584.4 plus 1,000 grams. Oh, we want to make it a percent, so we'll multiply by 100. And that'll give us a 36.9% by mass solution.